We are here to present our work, VLGrammar, Grounded Grammar Induction of Vision and Language. As we know, inducing the underlying structures in grammars, especially partial hierarchies, from raw data is a long-standing challenge. While grammar is an essential representation of natural language, it also exists ubiquitously in vision to represent the partial hierarchies. While the study of the hierarchical structure of images has a long history, the structure is mainly predefined by humans and studied across images. Therefore, challenges remain as first, how to represent flexible partial hierarchies that vary with images using an identical network, and two, how to learn structure automatically without predefined templates. With the development of unsupervised learning techniques, the unsupervised grammar induction for natural language has recently made satisfying progress. These works formulate the grammar induction of language as a self-contained system that relies solely on textual corpora. This notion is different from cognitive grammar, a concept from linguistic theory. Cognitive grammar argues that it is pointless to analyze grammatical units without reference to their semantics, which is grounded and structured by patterns of perception, such as vision. There have been some works on visually grounded grammar induction. They focus on aligning the image feature to language grammar by means the hierarchical structures in the image. This is inconsistent with cognitive grammar's notion that a constituent's semantic value does not reside in one individual image base, but rather in the relationship between the substructure and the base. Therefore, we present VLGrammar, a framework that learns grounded grammar induction of image and language jointly. First, let us introduce the party dataset. Party contains 10,000 3D objects paired with natural language sentences collected via Mechanical Turk and spanning across 4 categories: chair, table, bed, and bag. Here's our framework. Our model starts from the compound PCFG for inducing the language grammar and generalizes this idea to vision, which are jointly optimized by a conjunctive loss. So the context-free grammar for language contains a 5-tuple, where each symbol represents an element in the grammar, such as non-terminal, terminal, preterminal, extra. Non-terminals N are constituent labels. Preterminals T are part of speech text, and terminals omega are words from a sentence. The big sigma is the vocabulary. Compound PCFG extends CFG by giving the grammar rules probabilities that are obtained using neural networks and compound vectors, and then we use insight algorithm to minimize the loss. We can define the similar compound PCFG for an image, except that we do not have a vocabulary, so the last rule does not apply. So we replace the last rule with a bottom-up perception that clusters the words into preterminals T. Note that in this equation, if a clustering has higher probability in PT given V, it gives larger weight to the grammar module PT given Z. Therefore, the clustering module and the grammar module boost the performance of each other. Lastly, we use a contrastive loss to jointly learn the grammar of language and image. So here is our experimental result. As we can see, our proposed VLGrammar outperforms all baseline models. Also, it boosts the unsupervised clustering accuracy by 20%. VLGrammar has good performance in image text retrieval due to the contrastive loss and can generalize well to unseen categories. Here are some qualitative examples of VLGrammar. Thank you.